Have you ever wondered why we experience multiple seasons in a year? Oh, it's already summer. Geez, winter already? Ah, back to spring again. In the first place, why is a year even a year? Why are there 365 days in a year? This can be explained by orbit, specifically the Earth's orbit around the Sun. Then the Earth's orbit can be computed by...
Wait, you're moving too fast. We need to define what orbits are. No, it's not the famous pizza place in Lipa City, Batangas. An orbit is defined as the path that an object travels around another object, which is considered repetitive. Various celestial objects, such as the planets, comets, and asteroids, orbit the Sun. An example is the Earth's orbit around the Sun as seen. As mentioned earlier, the Earth's orbit around the Sun is 365 days. Now, going back to the different seasons, we actually...
Wait, hold up. The look of this orbit is quite similar to something. I just don't remember what it is.
Is it a donut?
No!
Is it a watermelon?
What? No.
I know, American football.
No. I just remembered what it is. An ellipse!
Oh, are those three dots used in sentences?
No. An ellipse is actually a set of points such that the sum of its distance from two other points, called foci, is constant, which exactly is equivalent to an orbit. Now, how are ellipses formed? Using the definition mentioned. Let's take a look.
So since an ellipse and an orbit are essentially the same, I think we can incorporate various phenomena about orbits to concepts about an ellipse.
I like that idea.
To start, Earth's orbital ellipse has four major points: the winter and summer solstices, and the autumnal and vernal equinoxes. The solstices represent the vertices, defined as the 2 points where the major axis passes through two foci, cutting the ellipse in half lengthwise. Like the saying goes, if there's a hole, there's a...
Hey, this is a math video. Anyways, what I think the quote Yanis was referring to was, if there's a hole, there are points that constitute the circumference of the hole. And just like that quote, if there's a major axis, there's a minor axis. The remaining 2 points, the autumnal and vernal equinoxes, represent the co-vertices, defined as the 2 points where the minor axis perpendicularly passes through the major axis, cutting the ellipse in half crosswise.
In this diagram of the perihelion and aphelion, the Sun lies in one of the foci of Earth's elliptical orbit. You might be thinking, ellipses have 2 foci, so how exactly does this explain that when the diagram shows only one? As Yana said earlier, the Sun lies in one focus of the ellipse. In order to find the other focus, we can use an equation.
Let's assign the perihelion distance as p and the aphelion distance as h. We know that the distance from a vertex to the center is a, so we come up with a is equal to p plus h divided by 2. And since the distance of a focus from the center is c, we can just subtract p from a to get the value of c. Assuming the center of the Earth's orbit is coordinate 0, 0, we can now just plug in the value of c in order to get the location of the second focus.
If we look at the orbits of the different planets, we can see the change in elongation and shape, namely Mercury, Earth, and Neptune. According to Kepler's laws, larger distance between foci should mean a larger eccentricity. But why is it that Mercury is the most eccentric when it's the planet with the shortest orbit? We also know that Neptune is the farthest planet from the Sun, so according to Kepler's laws, it should have the most eccentricity. But why does it have the shortest? The eccentricity of Mercury is so large because its variation in solar distance, which is the aphelion and perihelion, is around 41%.
Okay, enough chit-chat. Yanis, wrap it up.
Alright, so we first talked about orbits. We first discovered that this is not the famous pizza parlor in Lipa. This is considered as a path of an object around another object.
Next, we had a major breakthrough wherein orbits look exactly like ellipses. Carl, give us a recap on ellipses.
Ellipses are not those 3 dots you see in essays. As you can see, they look like this, which is very similar to orbits.
Exactly. Aside from those, we also related various phenomena about orbits into concepts about ellipses. We tackled the concept of solstices and equinoxes and its connection with ellipses as vertices. We tackled the concept of perihelion and aphelion of the orbit and its connection with the foci of the ellipses.
Finally, we tackled the different orbits of planets, alongside the relationship between the distances of their foci and their eccentricity.
Well, looks like our job here is done.
Indeed, Alex. Let's bounce.
Also, do try Orbit's Pizza Parlor in Lipa.